Hello, I'm WP Swazo, and I'm here to talk to you about separating the income effect from the substitution effect with use of indifference curves. First, I want to say that this exercise has been around economics for generations, and when understanding the plight of the consumer, separating the income effect from the substitution effect is a very basic examination. Uh, This is shown with a biaxial graph, just like the one in high school math. So what I'm drawing here are units of y, and this here horizontally are units of x. So a budget constraint is a diagonal line that looks like that. And it says you may have this many x, spending all of your budget on x, this much of y, spending all your budget of y, or an infinite different number of combinations in between. I shouldn't say infinite, it's only infinite if the units are splittable, like say being in a delicatessen, you could buy a pound and a half of ham or a pound and 3/4. The trade-off is constant because stores don't care if we spend all our money on milk or cereal, just so long as we pay for what we take. If y becomes cheaper, for example, this line becomes steeper. So a cheaper y would cause this budget constraint to have a more negative slope, a steeper negative slope. And the area of this curve, or the area of this triangle, the area behind this line, represents buying power. So this is buying power in here. If we get a pay raise, then we could buy both more of y in x, and the area behind the budget constraint expands. That shows more buying power. Less buying power if we suffered a pay cut, or if we move someplace with higher prices, it looks like this. So less buying power shifts the budget constraint southwesterly, more buying power pushes it to the northeast. If we want to talk about indifference curves, and indifference curves represent bundles that we are indifferent between, meaning they all have the same value. And the reason why they curve is because we are overcompensated for unbalanced bundles. I say again, we are overcompensated for unbalanced bundles. Looking at this here, if these are jugs of milk and boxes of cereal, we want to have, one jug of milk for each box of cereal. But as we deviate from that 50-50 split to get a to give away another box of cereal, this time we'll want to have 2 jugs of milk in recompense, or to give away a jug of milk, we want 3 boxes of cereal back. So this is why the indifference curves are bent. On the ends, they bend further away from origin, because if we take or accept an unbalanced bundle, we have to be overcompensated. In other words, we prefer balanced bundles. 2 other things about indifference curves are these. They cannot cross. If they were to intersect, the message of that means that more of both is not better, and that's not true. In economics, more of both is always better. And to get to a higher indifference curve, takes more income. All right. And that leads me into the linchpin of this exercise right here. If there's a change in price, the 2 things are happening. If this is our budget constraint and the price of y becomes cheaper, we have two things happening. We have more area behind the budget line, so that's more income effect, but the slope, the trade-off is also changing. So imagine if as Y becomes cheaper, you suffer a pay cut. So as Y becomes cheaper, you suffer a pay cut. So that would be a new budget constraint looking like this. So imagine if we start on this first budget constraint right here. Y becomes cheaper, so I'll call this picture discount Y. And then you suffer a pay cut. So a pay cut would be this parallel budget constraint. So the thing about this third and last parallel budget constraint, it has the same area as your original budget constraint, but it is reflecting the current prices. So that's what we're trying to do here. This line right here is substitution effect only. There is no income effect because this triangle that I'm going to trace right now has the same area as this triangle right here. So no income effect, all substitution effect. So if there's an event, there's going to be a total change. If from the total change we subtract out the substitution effect, it is going to leave us with the income effect. Hopefully this board doesn't fall down. Okay. All right, so let's look at this graph over here that looks pretty cluttered, but I hope to sort out that clutter by explaining. If you see point A is right here. So, first of all, the title of this graph is a discount on X. So in the beginning, we can only afford this much of X, but it becomes discounted and our maximum units of X expands out to that. Changing the price of X has no effect on our maximum units of Y that we can afford. So in the beginning, we are purchasing 10 units of X and 17 units of Y at point A. I say quickly, in the end, after X is discounting, we're purchasing at point C 20 units of X and 15 units of Y. But to get there, we have to take an intermediate step. So we begin at point A by buying 10X and 17Y. X becomes discounted, but can you imagine as X is discounted, we take a pay cut or our income is reduced? Reduced exactly to offset the savings we get from the discount of X. That's what this intermediate line right here represents. It's parallel to the new budget constraint. So point B, from A to B, is substitution effect only. It has to be, because our new budget constraint has the same buying power as the old budget constraint. So A to B is substitution effect only. So substitution plus 6. 10 to 16 is plus 6. A to B on the x-axis. X-axis is done. A to B on the y-axis. Looking at this, it's 17 to 15. So substitution effect, -5 on the y-axis. When going from B to C, that is all income effect, because all of the substitution effect has been captured from A to B. So looking at B to C for units X is income effect plus 4. B to C for units Y, B to C for units Y works out to be, going from B to C, plus 3. 12 to 15 is plus 3, so income plus 3. So looking at this, for product X, the income effect and substitution effect are working together. They culminate to plus 10. So at A, we have 10x, and we go to 20. Y is more complex. Y, we have a negative substitution effect and a positive income effect. Why is that? If the product you buy the most is discounted, that money freed up you can use to spend on anything you want. So the income effect is positive. Substitution effect is negative. If you are in a situation where most things are being discounted and there's a few stubborn items that are staying at their same old stubborn price, the substitution effect to that item or to those items that refuse to give a discount while everyone else is discounting is negative. So as we see here, the substitution effect here is negative 5. Negative 5 versus positive 3 leaves us with a negative 2. So looking at X, we start with 17 and we end with 15, a difference of negative 2. I hope this has shed light on indifference curves and how they are used to separate the income effect from the substitution effect. And I thank you for watching.